morning to everyone. After previous classes, today we're going to discuss another topic for you of chapter Optics Class XII Physics. That is refraction at spherical surface. Refraction at a spherical surface. Refraction at a spherical surface. You kindly note down the headlines. That is our today's topic. I hope you have gone through the previous topics. Refraction at a spherical surface. We are very familiar with a spherical surface, plane surface. We have discussed all these things in the previous class. So let's not make delay. So let's go straight to the topics. Refraction at a spherical surface. For that, we have to consider a spherical surface first. So let us consider a spherical surface like that. Suppose this is a spherical surface. This is a spherical surface. This is its axis. We have considered to be, and this is a separate medium and this is a separate medium. We have assumed, let us assume that refractive index of this medium is mu2 and refractive index of this medium is mu1. Considering mu2 is greater than mu1, so once you consider that mu2 is greater than mu1, so this medium will be optically denser medium since the refractive index is higher, and this medium will be optically rarer medium. Now if I make a ray of light traveling from this medium to this medium, that means suppose it is traveling from this particular medium from optically rarer medium to optically denser medium. So if I make the normal here, suppose this is a normal, understand? If I make this normal, this is going to be angle of incidence. You have know all this thing, or you have seen before what I have drawn it. This is optically rare medium, this is optically denser medium, and light is traveling from optically rarer to optically denser medium. Then we have found that once ray of light travel from optically rarer to optically denser medium, that refracted ray bends towards the normal. So in this medium, the refracted ray will bend towards the normal. So like that, and this is the angle automatically going to be angle of refraction. And suppose this is the image of this object and this is the point. Suppose this is point C, this is point P, this is point R. We have assumed nothing critical, very simple diagram. Simply light is traveling from optically rare to optical denser medium. This medium has got mu1 refractive index and this medium has got mu2 refractive index, where mu2 is greater than mu1. Now if I give the name of this angle, suppose this angle is angle alpha, this angle and this angle will also get some name. This is beta and this angle is suppose gamma. So this is alpha angle I have assumed, this is beta angle, and this is gamma and this is beta angle I have named them. Now I hope you have understood the diagram very easy. Okay, so and if I apply the Snell's law here, applying Snell's law, we find what was Snell's law we have studied earlier. If I apply Snell's law in this particular two medium, what I can write, that mu1 of sine of angle I is equal to mu2 of sine of angle R. This is mu1 of sine of angle I is equal to mu2 of sine of angle R. This is according to Snell's law. Now if I consider that these angles are to be very small, If I consider that these angles are very small, then sine of angle I will become equivalent to only angle I, and sine of angle R will become equivalent to angle R. So if I write, if the angles are too small, then I can write mu1 in the place of sine I, it will be only I. Mu1 I is equal to mu2 in the place of sine I, it will be R. Mu1 I is equal to mu2 R. When it will be possible? If our angles are too small. Again, in this case, one more thing you can find, since I have considered here, this is alpha angle, this is gamma angle, this is beta angle. As you can see, this angle I is exterior. This angle I is exterior for triangle. This angle I is exterior for triangle ORC. Understand? This is triangle ORC. If I consider this triangle ORC, then this angle I will be exterior for the triangle ORC. So then angle I is equal to, I can write, exterior angle is the sum of two interior angle. That means I is equal to alpha plus gamma. I can write I is equal to what? Alpha plus gamma. This is number 2. How I have written? As you can see that this angle of I is the exterior angle for triangle ORC. So it's very fortunate that exterior angle will be the sum of two interior angle alpha plus angle gamma. Similarly, again this angle gamma, again this gamma is what? Again gamma is exterior for, this gamma is going to be exterior for triangle RCI, understand now? This angle gamma will be exterior for triangle RCI. Then I can write that gamma is equal to angle R plus beta. Gamma is equal to angle R plus beta. Understand now? If angle I is equal to alpha plus gamma, in the formula by exterior and interior angle, so similarly gamma is going to be the sum of angle R plus angle beta. So here I can write that angle R is equal to gamma minus beta. Let us consider this is to be number 3. I hope you have got this particular point. Okay, very simple things. Now if I take this side in order to finish this derivation, what I can find that this is number 1 equation, this is number 2, this is number 3 equation. Now putting the value of angle I and angle R, putting the value of angle I and R in equation number 1, we find in equation 1, how I have written, putting the value of angle I and R, that means the value of I and R, which we can find from angle 2 and 3. If we put the values in number 1 equation, then what we can find? We can find that mu1, what is the value of I? The value of I is alpha plus gamma, that is alpha plus gamma is equal to mu2. Mu2R, value of R is your gamma minus beta, that is gamma minus beta. So I can write this implies mu1 alpha plus mu2 gamma is mu1 gamma. This is mu2 gamma minus mu2 beta, that is equation number suppose 4. 1, 2, 3. This is equation number 4. We have got these things. Clear? Now you can see this is the alpha angle, this is the gamma angle, this is the gamma angle, this is the beta angle. Now we can also find out, we know that what we know? We know that angle is equal to arc upon radius. This formula you have found already, that angles can be found by arc by radius. So by applying this formula, alpha is equal to, I can write alpha is equal, this is the alpha angle. Now how can I find the alpha angle? So this is the radius, supposed to be, if I make this radius like that, this is going to be radius. Okay, so this RP or PR is the radius. So in case of alpha, I can find this is PR by radius is OP. PR by OP you can write. So in case of alpha, I will write PR by OP. PR by OP. This is for alpha. Again for gamma, I can write similarly. Gamma is equal to, the arc is similar, that is PR, but radius will be what? PC. PR by PC. This is PR by PC for gamma. Similarly for beta, I can write, for beta is equal to, arc is common, that is PR, and your radius will be PI. This is PR by PI. This we have find from this particular formula, that angle is equal to arc by radius. Now putting all this value in number 4 equation. Now from number 4 we find. From number 4 equation, what the 4 equation was? Mu1 alpha. So I will write mu1 of PR by OP plus mu1 of PR by PC is equal to mu2, this is gamma. In the place of gamma, same thing will come, PR by PC, and it is minus mu2 of, what is this, beta. Beta is PR by PI. Now if I cancel this PR, this PR, this PR, this PR, so I'll find mu1 by OP plus mu1 by PC plus PC is equal to mu2 by PC minus mu2 by PI, I can write. Understand? Now again, two things will come for you. That is very premier things. That is your OP. What does this OP? What is this OP? What is this PC? And what is this PI means for you? I am telling you, this OP is the what? Very simple. Object distance. This PC is what? Radius of curvature. This PI is what? Image distance. This OP is object distance, and this PC is your radius of curvature R. This PI is image distance phi. So I can put the value right here. This is implies mu1 by OP is the object distance, that is supposed to be minus of u, because object distance is always negative, plus mu1 by PC. This PC is going to be radius of curve, that is positive. Mu2 by PC is R. Radius of curvature is going to be positive in this case, because they all lying in the right side. Then minus of mu2 by what is this PI? PI is the image distance, that is also going to be positive. Now if I arrange them, if I bring this thing here, mu2 by V minus mu1 by U is equal to mu2 by R minus mu1 by R. I can arrange them. So if I write them again, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. That is all about the refraction at a spherical surface. You can derive. Okay, refraction at a spherical surface can be established by this particular formula. If you want to find out the refraction at spherical surface, then formula will be automatically placed. Mu2 by V minus mu2 1 by U is equal to mu2 minus mu1 by r, and that is all about this particular concept. So what is important for you? You should practice hard and should not go for by hiding on this process. Very simple thing. The next video will come in with lens maker formula. Till then you keep practicing. Any doubt, inbox me. I'll be right here to help you. For today, thank you so much.